Cool. We won't wait for him, unfortunately. Let's just carry on. He got the idea completely, so he was 100% correct. So how is it possible that 34 only turns into 18? Cool. So now what you're going to do is you're going to do exactly the same equation. So you're going to start with H2. You're going to add O2, and you're going to make H2O. But this time I want you to balance first, and then do the same thing. Cool. Balance first and do the same. Cool. So in other words, balance it first and then do everything that we did over here in terms of working out the molar masses and then adding them together and then see what you come up with. Cool. So balance it first and then do everything exactly the same like we did with the first one. Sorry, Dacha, if you missed anything, all I'm saying is we're going to take exactly the same equation. We're going to balance it first. And then after you balance it, you're going to do exactly the same that we did over here. Cool?
Okay,
so balance, yeah, good. So balance it first and then do exactly the same. So you're going to make the columns and you're going to add everything together.
Sir,
Yellow?
can you share the screen, please?
I can, of course I can. Sorry, I forgot that it cut out. I need to share again. Thank you for reminding me. It'll be on in 2 seconds. Let's just quickly press the button here. Just give it a second. My Wi-Fi's been cutting out the whole morning. There we go. Okay, so exactly the same equation, exactly the same question. But the trick here, or the difference is you're going to balance first. So balance first and repeat. When I say repeat, I mean do everything that we did in the previous one. So you're going to add the molar masses and everything together and see what you come up with. Cool, just let me find the participants. There we go. Laura seems to be done. Mia seems to be done.
So we balance the equation and then?
So you balance the equation first, and then you repeat this process. So you can make the little columns like the ones in green over here, and then you add the molar masses together. The only difference is this time when you add the molar masses together, you have to multiply by whatever number you use to balance it, because there's going to be 2 or 3 or more of that same molecule. Cool. So you'll have a number in front of the H2 or a number in front of the O2, for example.
Okay, sir. Thank you.
No problem. So I'll start getting everything ready. So what we're going to do is we're going to do exactly the same thing. Break it into that. We're going to work out the molar mass for each one. And then we're going to add them together to get some sort of final answer on that side over there. Cool. Sorry, for the guys that are done, we're just going to give them a few seconds. Not seconds, a couple of minutes to think. Just quickly give another thumbs up in case I missed. I saw Laura and Mia, but I didn't see the rest of you. Just if you have finished, just give another thumbs up quickly. Yeah, Mia's still done. That's good. Cool, Dacha is done. Good. Dacha, just before I get the final answer, tell me now, after you did the whole process, does it make more sense or does it still not make sense? Where are you feeling now?
Well, it makes more sense, but I understand.
Cool. No. I'm not saying it didn't make
Everything.
sense to begin with. What I'm saying is that once you've done this final calculation, you get an answer that makes a lot more sense. If you know what I mean. Sorry, my internet's a bit slow, so you probably have replied. I just haven't heard it. Okay,
Yes.
so good. Dr. talk me through it quickly. So molar mass, balance the equation first. What numbers do we need to put into balance? My internet is really slow. Sorry. Let's see if Laura can try. Laura, can you balance the equation?
Yes, sir. So you're going to times the H2O with 2 in order to
Correct.
make the oxygens the same.
Correct.
And then we need to fix the hydrogens, also times it with 2.
Also times it by 2. Perfect. And that balances that. And then start with the molar masses. So calculate the MR of everyone.
So we know the molar mass of H2 is 2. So we're going to
Correct.
times the 2 with another 2.
Correct. So there's 2 because there's 2 hydrogens, plus there's the 2 in the front. And then the oxygen.
So well, we know it's 32 because
Correct.
it's
We know it's
16 times
32.
2.
Correct.
The H2O, we know together it's 18. So we're just going to
Correct.
times the 18 with 2.
Correct. And that'll give us the 36, if I'm not mistaken. Yeah, that makes sense. Cool. And then if you add these two together, so if you add MR plus MR and that MR, then you'll have 4 plus 32 is going to give you 36, and 36 goes to 36. And does that make more sense than what we had over here? Cool. I think that does, yeah. I think that makes a bit more sense. Sorry, the internet's a bit slow. Maybe you guys are replying. I just can't hear. Cool. So 36 makes 36. And this makes sense because we don't lose any mass. So we don't create or destroy anything. So whatever we have to start with in terms of mass, all of that mass gets used up. It gets converted. The bonds break, the bonds form, and we end up with 36 as a product. So we don't create or destroy mass. So we can say here that mass is conserved. Cool. So mass is conserved. And that's why it's important to balance the chemical equation, because once you balance the chemical equation, you'll see that the mass is also conserved. Okay, so we're gonna carry on with exactly the same example. We're not going to change anything. We're going to do the 2H2 plus O2, and we're going to make 2H2O. And the only thing we're going to write underneath it is this number, and this number. So we're going to write the 4 for this one. And instead of writing a plus, what I'm going to do is I'm going to write it as a colon, and I'll explain why now. That's going to be 32. And what I'm going to do is I'm going to write that as a colon, and I'm going to say that that is 36. Okay, so what I want you to do now is I want you to carefully think about this. When you think about this, this could be a recipe. This could be saying, take 4 grams of hydrogen, add it to 32 grams of oxygen, and you're going to end up with 36 grams of water. But would you agree with me that what I've written here above, would you agree with me that this here, sorry, that's a bit dark. Let's go to yellow rather. Would you agree with me that this over here is just a ratio? Would you agree with me that that's just a ratio of the chemicals?
Yes, sir.
Cool. So in other words, the ratio of hydrogen to oxygen is 4 to 32. The ratio of hydrogen to water is 4 to 36. And then you can say the ratio of oxygen to water is 32 to 36. So let's do a very simple example. If I was literally just going to make double the recipe, so if let's say I used 8 grams of this, so this should be a plus over here, not an arrow, that should be a plus. The question is, how much of that will I need? And the question is, how much of that can I make? Just quickly write down an answer and then give me a thumbs up when you're done. Cool. So if I take 8 grams of hydrogen, how much oxygen do I need? And how much water can I make if I follow the ratio perfectly? Cool. Just write an answer and give a thumbs up when you're done. Cool. Dacia's done. Laura's done. Laura's done again. Good, good, good. Inesh is done. So just Mia, Tandy. Write down something. Just think about it as a ratio and then write something simple. And And Tandi's done good. Okay, so I hope I can hear you, but Laura, can you just give me the answer? How much oxygen would I need? Laura. Sorry, my internet's very unstable. It's telling me that it's not good. Ooh. Anybody, let's try Tandi. Tandi, can you give me an answer?
So I said 64 grams for
Oxygen?
Oxygen. And
Correct.
72 grams for the water.
Correct, 100%. And the reason is because you notice that all we did was we doubled the recipe. So all we did was times that by 2. So if I times the first one by 2, I times the second one by 2. And if I times that one by 2, I times everything by 2. So I just doubled the recipe. And then you could do exactly the same thing. And you could say, well, if I take 2 grams of this, then how much of this and how much of that? Just quickly write down an answer and then give a thumbs up when you're done. Cool, Laura's done. So it's a very simple example, so it shouldn't take you long. And then Laura, if you can hear me and if you can give an answer, just quickly tell me what the answer is.
So we divided the 4 by 2, so we're going
Correct.
to divide the 32 by 2, get
Correct.
16, in the 36 by 2, which is 18.
Correct, 100%. So it's just a whole number ratio divided by 2. Okay, so those are simple examples where the ratio is easy because I just doubled it or I just halved it. But then you could think to yourself, you could make the ratio far more complicated where it's not a perfect whole number ratio. So we're going to do exactly the same question again. We're just going to use more complicated numbers. So this is going to be plus O2, and this is going to give 2H2O. That stays the same. And then all I'm going to do is I'm going to write the ratio. The ratio is 4 to 32 to 36. And I want you to remember that this is just a ratio. So that's just a ratio. Then I can give you an ugly number. Then I can tell you, start with, what's not a multiple of 4? Start with 30 grams of this. Ooh, and then the question is, how much of this and how much will you produce? Cool. But I think rather skip the produce one. Just do the ratio of the first two so that it seems like an easier question. So focus on the ratio between this and that. Forget about the last one for now. Cool. So if I give you 30 grams to start with, the question is, how much oxygen do you need? Cool. Oh, Laura's done already. Wow. Cool. But for the rest of you, just quickly have a look. Oh, you guys are all done. Excellent. My goodness. Okay. So maybe you did revise your ratios and this is easy. Oh, wow. Everyone's done. Okay. So Mia, do you want to talk me through it?
So I think that since you multiply the 4 by 7.5,
correct,
you would multiply the 32 by 7.5 as well.
100%. And the answer would be?
240.
Correct. Oh, I don't actually know if that's correct. Is everyone happy with that? I didn't check it with a calculator, but I'm sure she's right. Cool. So you're happy with that. And just quickly, briefly talk me through, how did you get the 7.5? Where does that come from? Where did you find that?
So I just said 30 over 4.
Correct. 30 over 4. And then you found the ratio. So, sorry, not the ratio. You found the multiplier. Ooh, and then what you did is you took that 7.5, which is the 30 over 4, and you timesed it by 32. Am I correct?
Yes, sir.
Correct. And would you agree with me that that's just another way of doing a ratio calculation? So all you've done is you've worked out the ratio of the 30 to the 4, and then you've multiplied it by the 32 to work out the ratio of the 240 to the 32. So in other words, if I take 240 divided by 32, it's also going to give me 7.5. Make sense?
So I have another method.
Yes, there's plenty of methods. There's 100 ways to do it. So I'll copy and paste the question quickly, and then you can tell me how you did it in your way. Just let me quickly copy and paste. And the more methods you learn, the better, because you'll realize that it's actually just ratios, and you can play around with it in any way that you want. So let me get rid of all of that. And then that's the starting thing. So what did you do?
So, sir, I've simplified the ratio to 1 is to 8 is to
1
9.
is to 8 is to 9. So you simplified it to a whole number ratio.
It's just easier to times it with 30.
Correct. So you saw that if 4 makes 8, then 30 is going to make 8 times as much. Am I right?
Yes.
Correct. And then you basically said that 4 goes to x. So you said 4 goes to 30 goes to 240. 30 goes to 240. But there's 1,000 ways you can do this. But if you understand ratios, would you agree with me that all you're doing is you're calculating a ratio? In whatever way that you do it, however you understand ratios is up to you. That's all you need to do is use ratios. Cool. Everyone happy with that?
Yes, sir.
Okay, good. So do you guys have another lesson now, like in the next 5 or so minutes, or do you have a few minutes? Can we go over 11 o'clock? Is everyone happy to just take 5 more minutes quickly to do one more example?
Yes, sir.
Yes,
Yeah.
sir.
Yes, sir.
Good. Okay, so let's not do it as a full example. What I will do is I will give you the question, and then you can do it, and then you can send me your answers, and I'll check for you whether it's correct or not. Okay, so I'm going to give you an unbalanced equation. I'm going to say that nitrogen reacts with hydrogen to produce ammonia. Ooh. So it's a real process. This is what it's called, the Haber process, and it's how we make ammonia from nitrogen and hydrogen. So it's a real process. Okay, so it's unbalanced, so you have to balance it first. So that would be step 1. Cool. So fix, that's step 1. And then the question is quite simple. I can literally just make up any number that I want. And I'm going to say, starting with, let's make it 50 grams of nitrogen. The question is, how much ammonia can I make? Ooh. So if I use 50 grams of nitrogen, the question is, how much ammonia can I make? So you've got to do that. And you basically have to just follow these steps again. So balance the equation, work out the molar masses of everything, find the ratio, simplify it if you want to, like Laura did, simplify it to a whole number ratio. That's also nice. And then basically find out, given 50 grams of nitrogen, how much ammonia can I make? Cool. Any questions about the question, or are you happy with that? No, you're good. Cool. So what you can do is just send me a WhatsApp with your answer, and I'll tell you if it's right or not. And then if it's wrong, I'll just tell you to go and have a look again. And then we'll keep trying until you get it right. Cool. I'll see you guys tomorrow. Be good.
So, sir, should we just send
Yeah.
you the ammonia?
Just the ammonia, correct? Just the answer, literally just the answer. You don't have to show me your working out or your calculation or anything. I'll do the calculation now, and if I know it's right, I'll know it's right. And then if yours is wrong, I'll just tell you, no, try again. Cool?
Yes, sir.
Awesome. So just send me a WhatsApp with your answer, and then I'll check it for you. And then we'll carry on with a
Thank
few
you,
more
sir.
examples tomorrow. Bye, guys.
Bye, sir.
Bye.